Welcome again to SplunkTalk, a Splunk podcast that's all Splunk and no junk. I'm your host, Birch,
I'm
with
Hal.
co-host. Hey, how'd you know what I
super
was going to
excited.
say?
I mean, I'm getting used to it, you know?
Yeah.
This
And
is
we've
like,
got
like old married couple stuff here.
stop. You always do this. And Dave McAllister is joining us today, our senior technical evangelist. We're going to be talking all about observability, monitoring end to end. But before we get into that, what?
3.5 hours.
For the next 3.5 hours.
Yes. All right. I hope you can go that long, Dave.
I actually think I might just barely touch the surface in 3.5 hours.
Okay. I like the optimism. That's good.
So I got one more check on my bingo card.
Okay.
IT Super Session.
Mm-hmm.
Yep.
I made the platform super session, and then I think there were 3 at once.
Oh, I wanted to go to that one. I could not find it.
Well, that was the one that was right. It was the same time. I mean, they're all, some of the super sessions were at the same time.
Yeah, you had to pick and choose. You had no choice. No, I'm going to all of them. You have to go back and watch the re-recorded version.
But they're all there, so we actually have the option. So that's cool.
Yes, we can.
Yes, we can.
Yes. Like your t-shirt too, Birch. That's a great t-shirt. Yeah.
Well, I was going to save it for the end, but you have 2 talks, cool. Right, Dave?
Yep, absolutely.
Why don't you plug them now, and then we'll plug them again at the end.
Okay, well, I just finished one on monitoring practices for modern applications called Seeing Red and Using Use. Red being rate error durations, and Use, of course, being utilization, saturation, and errors for that. Of course. So it's very simple language. So that came from the golden signals, which are, of course, latency, errors, saturation, and traffic.
All right. Hold up a second. Like, I do want to get into this stuff. This is awesome. But we do like to talk about the people behind the data. So before we get any further, Dave, you and I have not met yet. So I'm glad to meet you. Tell us a little bit about yourself.
Geez, I'm an open source geek. I'm a standards wonk. I've been open source, I hate to say it, longer than open source has been a term. Open source was coined in 1999 in Larry Augustine's office on 100 Hamilton in Palo Alto, California, just to be precise for that. And I've worked for big companies, little companies. I've done 9 startups, 1 abject failure, 6 sold.
What'd you call me?
And two that are still in existence here. And
that sounds like a great ratio to me. Well done.
Yeah, it's actually been pretty amazingly, since it's 1 out of 10 is the normal.
This is a really roundabout way to tell us that you have a Tesla.
Yeah.
So wait a second. Going back to the days of open source when it was new, did you actually own a shareware copy of Commander Keen on the Commodore 64 or
No, I never ran on a Commodore. I did have the Ataris, including the Atari 400 XL with 50 I tell you, megabytes of hard disk storage. So just to
okay, very good. I feel like we might want to devote a section of our talk to all of the computers that we've had in our past lives.
Yeah,
that would actually be a very fascinating conversation.
We should just take over the Twitch stream and do that for the rest of the day and forget about the party later. Yeah,
it probably would pick up pretty well there. And then, as we all at Splunk, we're 1 million data points here. So my favorite 3, as I'm owned by 3 cats, I am used to being ignored. No problems with that.
Sorry, did someone say something?
Number 2, I spent 10 years as a soccer ref. I am used to half of everybody disagreeing with me at any given moment, no matter whether I say it or don't say it. And third, I'm married, so I can have a witness that I do not read minds. So feel free.
Man, that's I was going to say I appreciate you about the soccer ref thing, but that would be lying. I mean, you cannot do your job right. There's no winning it, and it's got to be a tough gig.
And another interesting podcast to be
but I've not
read as a ref. Yeah.
I just think that at some point we have to one of us has to get very slightly hurt, but make it very, very dramatic, just so that you feel like comfortable and surrounded by what you're used to.
Yep. And then the other talk is coming up later, which is how we move from monitoring to observability, how the two work together. And that's today, I think, at 3 p.m. Pacific time.
Okay, let's start
nice.
with a little bit of basics, not a lot of basics, but let's start with the definition that you would like to share with us about observability.
You know, that's a great place to start, because that definition is kind of like open source. What the heck it means is whatever whoever said it wants it to mean. For me, observability is around new sources of data. It's getting data from inside of our application, inside of our environments that we didn't normally get to see. It does require that we do things called instrumentation, that we actually start pulling the data. But I'll use a standard example. I drove a 2005 Ford diesel pickup, and every now and then this really weird little light would come on the dashboard and say, "You're broken, limp home." Unfortunately,
you just have to fill the gas tank up with that one.
Yeah, no, fortunately not. Unfortunately, there was no information about what it meant. Even when you went and asked the computer would go, "Huh? I have no idea what you meant." So you now have a monitoring solution, but you don't have an observable solution inside of here. What it actually turns out, by the way, is that the oil filter was clogged. It's built into the engine. You have to rip the engine apart to pull the oil filter out for the turbo cooling system. And Ford didn't actually want you to know that the problem was, but even if you took it to the Ford dealer, they had no clue what the problem was.
You couldn't just plug in and
nope.
OBD?
OBD?
You down with OBD?
Nope. OBD2, nope, didn't work. It would actually come back and say, "You've got nothing wrong with you." Oh. And that's where we start breaking down this concept of we need the data to be able to monitor for these new problems. And we need the data to be able to go back and find these new problems. And observability is all about finding out what your systems are trying to tell you, even when you don't have a clue what questions to ask. And so it's a data to analytics, a data to monitoring, and a data to response problem. So from my viewpoint, observability is all around the data. And I can't think of a better place than Splunk to be looking at data, because, you know, data everything is definitely the case here.
So go ahead, Birch.
Oh, go ahead, Hal.
Okay, thank you.
That's so both of you go ahead at the same time.
Okay.
So
is it like when you
log metrics and traces, right?
Yes. And so we do break this down into what's normally been called the 3 pillars, but I dislike it because pillars says, you know, sort of feel like if something disappears, it all falls apart. It's the 3 classes of data. And those classes of data, as you pointed out, are logs, metrics, and traces. And they usually are, you look at metrics first because they're easy, they're fast, and with streaming capability, I can get alerts in seconds. I don't have to process anything, it's just there. From there, I want to know where something went wrong or what part of something went wrong. Traces will tell me that. And sooner or later, you're going to end up at the source of truth, the logs. So those 3 things give us the ability to do this deep diving of functionality, this deep pieces of figuring out what the heck is going on here. The other piece, by the way, just to let you know, is that we see observability being used a lot for playing not only what went wrong games, but what the heck is just going on as well. Normality is just as important as outliers. And observability gives us the normal states far easier than we can get it from almost any other source.
So
your turn.
Please. Okay. So I'm trying to relate this back to like my experiences when I was a customer. We certainly, like, let's say we're running like a WebSphere platform. We've got application logs coming out. We've got JVM logs. We've got logs from the entire WebSphere management system. Where would I be looking at? How would you apply observability to that traditional stack?
So interestingly enough, you'll often hear people talk about how observability is all about the cloud. But as you're just pointing out, we're not all just about the cloud here. Observability goes into that same category. For instance, in a log environment, you probably have have interesting metrics data that you need to metricize to come in to actually take a look at it. One of my favorite lines, I used to work for a different log search company. Now, nobody reads log files for fun, very honestly.
I don't know that that's accurate, but go ahead. I mean,
okay, nobody who isn't yes, never mind. For that,
I have
but
read RFC specs for the SNMP protocol.
I might get some dopamine drip when I read a Splunk D log starting up cleanly.
Okay, that I can relate to. Okay, that one I'll give you that one. But basically, when we look at this, we're trying to do this. You've got a middleware environment. You've got, at the very least, a front-end environment, talking to a middleware environment, talking to something on the back end here. And something can go wrong in any of those places or in the transmission between those places. So a request flows through your system, comes through, hits a middleware, gets assigned to somewhere else. Now let's
Like
take that
back
to the
down to
next
the
step.
database or something.
Right, and then it's got a round trip. It's got to come back to you. Now let's assume that it's a internet connected client. So you're coming in through a browser. And now you have another level of complexity in the browser communication that's going on for this. What can easily happen is you find out on Twitter that your customer no longer can order his famous Acme Anvil widget to be able to track down the coyote.
Yeah, or like, I'm just making up an example here, but if anyone were struggling to like get into a conference platform through the web UI or something.
That's very software review.
Yeah, it's very just
observability. Observability will tell you what's happened at each of those steps. And
so all the way from the user to the web browser to the web server to the application server database all the way back?
All the way back. And so what we're now talking about is this thing called Digital Experience Monitoring, DEM, which is made up of RUM, R-U-M, Real User Monitoring, and Synthetics, just to make life really complex. By the way, one of my coworkers, Chris Riley, likes to talk about how IT technology weaponizes vocabulary faster than anybody else in the world. So, you know, I'm now coining synthetic.
Did they say that to you at IRL?
Probably, but, you know, I was on an async model at that point in time, and my bandwidth was really, really sucky, so I didn't see it until much later. But yeah, so nonetheless, we weaponize technology here. But when we're looking at this, we're looking at from where it started to where it ended. The only reason we actually monitor stuff, the only reason we care about observability is, quote, keeping users happy. If nobody complained that the system was up or down, it doesn't matter whether we're watching it or not. We're here. So now observability is really focused on trying to make sure that the user experience is as clean as possible. And users really only care about kind of three things, very honestly. This request, its success or failure, and how long it took. So the other side of this is we live in an instant gratification society, you know, where 3.7 seconds means you go to a different website, where a much maligned Microsoft study in 2008 says that humans have an 8-second attention span. I'm sorry.
Sorry, what was, yeah, what are we
I was
doing
not paying
here?
attention.
Yeah, for that.
Yeah. Good job, guys.
What did I just say? For this, but nonetheless.
We all made the joke. Yay.
That's the model we live in here. And even in your environment where you can actually track it down and go, aha, there's the bad system here. Wouldn't it be nice to know if that bad system was being caused by a network card initializing and rebooting itself, or is caused by the fact that your service mesh software has suddenly decided that it doesn't like talking to this other service, or that your middleware component has simply said, oh yeah, I'm working just fine, but not actually doing anything. And so observability gives us those insights.
So, I mean, conceptually, this all sounds excellent. Make it real for me. Like, how do I instrument
And I know that, you know, we've been talking for a few years now about the evolution of what modern software means, and everything is you know, public cloud or a blend and microservices. So that's kind of the backdrop of what has been happening. Yeah, like Bert said, like, how do we make that real?
Yeah, and real is almost as overloaded as open and possibly even observability these days for this. But nonetheless, you're sitting there, for good or bad, very few people sit around and knock and stare at screens all day. Um, I wear glasses now probably because I had to sit and knock and stare at screens all day for a part of my life. But now I want the system to do the work for me. And I don't care how simple or complex your system is. Even if you think about it from a microservices environment, a service does one thing well, not as small as possible, but as small as necessary. But inside that service, it may be doing different functionalities. You just got bigger services in your client, middleware, backend environments. And so I can still do that. Now, to make it work, you need to be able to do generally what's called instrumentation. The nice thing is that most of us are really smart these days, and we use auto instrumentation libraries. Just link the library in, and the magic happens.
So like if I have a Java-based app, like in the example before, I don't have to reinvent the wheel. I can use some existing well-defined. Is that like open source libraries?
You can, in our case, we're fully committed to an open source project that does that called OpenTelemetry, which to close the loop is right now coming up on GA for metrics and traces. And interestingly enough, they're working on the log piece. They'll be the only open source telemetry tool that actually uses all three classes of data. Nice thing is that, by the way, that log spec piece came from Splunk. So we have a little bit of knowledge about what's going on in the log environment as well. So using automated instrumentation, if you're in Java, you're golden. Just plug it in and you're going to start seeing data instantly. It's not going to be like, I've got to gather 4 weeks of data. I'm going to get stuff right now for that. And the nice thing is I don't have to rewrite any code. If I don't like it, go back to the original libraries. Don't change anything. I've heard people go, the only way to do this successfully is to rewrite your code to tell me what you want. You do that means every time you change your code, you get to rewrite your code. And it means that every time that you decide to switch to a different tool, you may end up rewriting your code as well. As a developer.
And ideally, you would want this to be abstracted.
Absolutely. As a developer, I don't want to have to rewrite my code for anybody's tooling. Very honestly, I don't want to. It's complex enough to write my code the first time.
I mean, how annoying would it be, and kind of the lacking of productivity involved in having to write non-functional code for your tools that actually don't add value to the widget that you're trying to ship.
And if you look at the average length of feature requests coming in for any application, it's miles long to begin with. We'll never catch up with all the feature requests to begin with. So don't add a feature request that says, oh yeah, put in this tracking data for me and make sure it works correctly. And by the way, I may change the tracking data that I want to see on a weekly by week basis or a day by day basis.
So does this fully replace that? I mean, companies have spent a lot of effort, sometimes in, for example, writing those transaction IDs to a log, and sometimes they've, there's a variety of tools you can do some of these things. You've got tagging software.
Yep. Dimensionality comes into play. And by the way, sensible telemetry environments take all of the stuff you're talking about and make use of it as well. And so in my world, my open source world here, tracing kind of started with the open tracing work. It started with products like Zipkin and Jaeger. Here, they also have their own wire protocols. They're widespread. Why would you just throw that away? Just use it. Use the data.
So it sounds like it sounds like we're talking about the selling point on not on almost like build versus buy, but like you use the open source ways of doing the instrumentation versus trying to build it yourself. So okay, I'm the customer. I'm sold on it. I'll use your instrumentation. Is the thing here that Splunk is doing is, are we providing a new way of consuming that data or viewing that data, or are we providing a way of generating that data through the instrumentation plugins, or both?
The answer, of course, is a resounding yes.
Awesome.
You want me to go into details? Okay. So yes, again, we started off by me using the phrase that observability is all around the data, allowing us to answer questions we don't even know to ask yet for this. That means that we get the data in, we need to be able to monitor it, we need to be able to analyze it, and we need to be able to respond to it. And that's where our tools are top of the line. Since we're using streaming functionality, you don't wait for results coming in play here. It's not unusual in a batch-based metrics environment that it'll update every 1 minute or every 5 minutes. So let's pick on clouds, for instance. We have this thing called serverless. An AWS Lambda's average warm startup time is 30 milliseconds. And the average running time for it is something along the lines of less than 3 seconds. Think about how many of those could go wrong if you had to wait for 1 minute or 5 minutes to find out something went wrong. All of a sudden, you're way behind your curve. That's happening inside of that picture just because you had to wait for your data to, quote, process. Streaming metrics win, and very honestly. The second thing is, people will talk about observability as data to noise problem. It's not a data to noise problem. It's not a signal to noise. It's the signal is your data. If you throw stuff away, which we quite often hear as a sampling model, you are letting somebody else ask questions that you don't even know to ask yet. Remember, our concept is we're going to answer questions we don't even know could occur. If you sample, you have had somebody else pick what questions you're going to be able to answer. And we don't throw anything away. We use every piece of metric, every trace, and every log, looking at all of the data. So you can always find out what's going on inside of that. And third, we made two announcements today about we're acquiring Plumber, we're acquiring a synthetics company for this. We will have the complete portfolio that comes into play that starts at the client and goes all the way through the entire functionality, as well as the DevOps culture. So we'll be able to shift left, do more advanced testing, be able to in a sense, also be able to track standards and norms. In my monitoring talk, one of the lines I use is there are two basic questions. How do you know something went wrong? And how do you know it ever worked in the first place? And with the portfolio, we are able to answer both of those questions at all times.
So we only have a few minutes left. I want to maybe go in a little deeper into something concrete. So what was something of your favorite of the many things we've been talking about? Which one kind of has you the most excited?
Of the new product stuff?
Yeah.
Yeah. So interestingly enough, RUM really feels important because, again, we only do this because we want our users to stay happy. Again, if nobody cares if it's running or not, we shouldn't care that it's running or not either. But users care about their individual transactions, what's happening right now. And by the way, it starts over. Every time they issue a new request, it starts over. RUM gives us that insight, while at the same time, the full fidelity nature lets us go back and say, oh, did it ever work for this user? And I can actually start crossing boundaries into security. Am I looking at somebody who's forgotten their password, or am I looking at an attempt for somebody to crack the system? And so given those pieces here, being able to see what the users are doing from the very front end all the way through to the back end means I've got a better chance of keeping the users happy. At the same point in time, I can pinpoint where the problems exist and get resolution faster as well. So I feel like I'm conducting. Sorry, I taught college at one point in time. I tend to write on whiteboards, and scribbling on my computer screen just doesn't have the same impact.
I can relate. I don't write on whiteboards, and there's a reason for this. If any of you have ever seen my handwriting, it's actually awful. And I don't know about you, Birch, but I've thought about getting a whiteboard or creating a digital whiteboard, using it in presentations, but it wouldn't be any better. My handwriting is awful. It's not really a fix for anything. But so it sounds to me like, the future is new and exciting, but almost confusing. I feel like there's a lot that has just landed at the same time. And this is the same thing that happens every conf. This is not new here, but really, I guess it kind of comes down to, perhaps some of the same old lenses as far as, our customers think Some of them are focused on security. Some of them are focused on IT. It seems like IT has gotten a lot more complex though lately.
Yeah, and that's a fair statement. IT has definitely gotten more complex. I'm not a security guy. I did work with the security team at a former company. I suspect security has gotten more complex as well for this. But again, it's a very complex space that you can start very simply. Just start getting the data and let's see what the data tells you, and pick the right tools to give you the insight and let you drill into the data. And you're going to find out things that you had no idea your systems were actually doing.
Awesome. So any last words, Dave, that you wanted to kind of leave us with?
If you can't tell, I can get pretty excited about this observability topic. Even though actually saying the word can trip me up as well, because observability is actually really hard to use constantly in talks here. But the thing to keep in mind is that this is not build the perfect cloud native application. This is let's find out what our applications are really telling us. And if you work at it from that viewpoint, it's an easy place to start and an easy place to evolve from. So don't be afraid of people telling you how complex it is. It's actually not that complex. Just basically dive in. I promise that the pool is deep enough that you can even dive headfirst if you want to.
All right, so would you go so far as to say data is like a box of chocolates and you never know what you're gonna... I forgot how that went.
So data is like a box of chocolates that you received in the mail. Not only do you not know what's inside the box until you open it up, once you do open it, you're probably going to have a pretty good time.
Nice. Are there any talks that you recommend people go check out from here? I know we've got some very cool featured speakers. Sounds like it should rhyme, but it doesn't.
So there's a couple coming up here. There's one, I don't remember the schedule exactly, but there's one tomorrow that is talking about open telemetry. And open telemetry is the way we're going to be getting data into all of our monitoring tools in the future. And it is the industry accepted standard. It is an open source project. And I really strongly recommend going that. The speaker is Steve Flanders. The other one is one that will go more into RUM and to Log Observer, or how we tie real user monitoring and how we tie basically logging that's built for the developer community together. That's, I think, later today. And Hema Mohan is doing that. And I've forgotten who Patrick Lynn. How can we forget Patrick? Jeez. Are talking about this. That's going to give people that are used to a log-first world a brilliant insight into how we can enable their logs to give them even more. So I would really recommend both of those.
Cool.
Awesome. Well, I think that's about all of our time for this session. We have another and another. It's awesome. Birch and I are having a lot of fun with this. Let's see, coming up next in about hour 20 or so, if my math is right here, we're talking about service intelligence for SAP, new stuff, solutions coming out of our IT Essentials group. We're going to have Martin Weiser and Kara Gillis on for that.
And at 45 after, at something after, you could check out my talk, which is going to be about infrastructure and workload licensing.
All right.
So awesome. You can do some Q&A there with me.
And don't forget, we are a podcast that's here after this stream is over. So SplunkTalk, Google that. You'll find us on YouTube and Facebook and Twitter and everything.
Subscribe, follow us here. There's nothing here. There's nothing here. All right. Thanks, Dave. Thanks, everyone.
Thanks, Dave.
Enjoy the rest of the conference.
Bye-bye.
Bye.